This is the start of a multi-week section on the cardiovascular system. There are several chapters in your book on the system. So first I want to start with what is the cardiovascular system? What components make it up? You may think primarily of heart. Well, that's an important one. We've got the heart. It's a muscular pump that literally is the driving force, creates the force to pump blood throughout the blood vessels. I just said the other two as well, right? So these three things here are all the three different types of blood vessels: arteries, veins, and capillaries that we'll come back to in a couple weeks. Blood vessels are just the tubes, kind of like tubes that carry water to your house. The difference is we do have to have transport across those tubes at times instead of like a faucet that turns on, opening up the water when you wash your hands in a sink. Unlike that, these tubes are completely enclosed. This is called a closed circulatory system. Other animals, a lot of insects, have open circulatory systems that kind of just leak out, kind of like the faucet of a sink. So these closed tubes are closed circulatory system, and that requires these capillaries to be able to transport fluids across their beds. So we'll come back to that, but that's the one caveat from them just being simple tubes. And then I already said this, the blood vessels, they're going to carry blood. So the heart pumps blood throughout the blood vessels. And these three components need to work together to provide nutrients, transport wastes to and from around the body. In addition to that, so blood pressure has to be maintained. So we'll talk about blood pressure in order to transport all these nutrients and wastes. And also fluid volume has to be maintained. So actual volume of fluid, not just blood pressure. So we'll come back to that as well. And lastly, this system is going to interact with the respiratory system, of course, in gas exchange. So we'll do respiratory system after cardiovascular in terms of how we get gases to and from the blood. So we're going to start with the blood. The blood's job is to transport cells and dissolve materials throughout the body. And this is important for homeostasis, right? So I want you to do a learning check first and name at least 4 things you can that are transported by the cardiovascular system, so via the blood. Okay, I'm going to go over this in this table. This is one way to break down transport in the cardiovascular system. This is a table that kind of makes sense to me for breaking down transport for things that go into the body. Oh my gosh, I did it again. Okay, we'll just do it with this. Things that go into the body from outside, things that are just transported within the body, and things that are going out of the body. So it's broken down by those 3 sections. And then each of these has where that thing is going from and to. To, you'll notice, is often all cells. For things that are going out of the body, from is all cells. So oxygen goes from the lungs to all cells. So these 2 are things that are coming into the body from outside. Blood needs to transport those around. These are things that are transported within the body: hormones, immune cells, clotting factors, and stored nutrients. And then these are things that are transported out of the body that we need our blood and our cardiovascular system to be able to do that. Carbon dioxide, heat, and waste. Waste actually could be more than just from the kidney. So the key point is here that blood transports a wide variety of substances, like a wide variety, right? Everything from tiny little oxygen, actually ions too, right? Hydrogen ions, potassium, salt, all the way up to big hormones, immune cells, whole cells, and heat, which is a different thing. And in all of these cases, though, the goal is to maintain homeostasis. So over here, I've got the variable that's maintained for each of these scenarios. So transport of all these components is necessary for maintaining homeostasis. And you could, so when we draw a feedback loop, we might start with a disruption in one of these variables here that then is going to cause a change in the delivery of that substance as part of the response. We don't always draw like blood vessels, blood carrying something as part of a response, but it's always going to be often going to be part of a response.